where the problem comes in. Yes, there is a force there, but now they're saying planet K, so to decide between those two, planet K exerts a force on the star. There, how many objects are involved there?
Two.
Okay, so if you are looking at this equation, it's, remember this small mass, I always say you must think it's you. So if you are on Earth, this would be your mass, not the planet's mass. To work, and this is actually the same as W, remember, equals mg. It's the same equation that you've been using since grade 8. This is just changed because of Earth to be 9.8. But if you're using this equation, there's only one mass. So also let yourself be led by that. In this question, there are two masses. So therefore, we'd rather use this first equation. Otherwise, you're going to have to do calculations, and we don't want to do that in a multiple choice. Now, here, so this was F. So it says planet K exerts a force of F on Sirius. Now we look, something's going to change. So you always start with what is given originally, and then you look what's changing. Now they say the sun is half the mass of Sirius. So this was when it was planet K and Sirius. Now the sun is half the mass of Sirius and 5 times closer to K. What would the force be on planet K, between planet K and the sun? So now you need to think what stays the same and what is changing. Does the mass of K still stay the mass of K?
Yes.
Yes, because we're still working with planet K. So that stays the same. But does the mass of Sirius still stay the mass of Sirius?
No.
What's happening to the mass?
It's, I would assume, increasing because it's the sun.
Don't do that. Read the question. It says here the sun has
half the mass.
Half the mass. Sirius, guys, is actually one of our biggest stars in the universe, and it was, it's all the Harry Potter things are all in the stars. I don't know who watches Harry Potter, but the sun, read the question, the sun has half the mass, so what is this mass going to change into? It's not going to be m anymore, it's going to be half m. So we need to add a half here with the m at the top of the line. Then the question said, and this is where people misread again, it says that it is 5 times closer to planet K. So is R still R?
No, it's 5 times closer.
Yeah, what does closer mean? Is R getting smaller or bigger?
The same bigger is going to be times by 5.
See, this is exactly what half the people did.
Don't you divide it by 5 then?
Yes, because if it's closer, look at this way, and if it was like this, and now you're saying it's 5 times closer, it's now like this. So what happened to the distance from there to there? It's become smaller. So you can't say that because you're reading 5 times, you just go 5. It's 5 times closer. So that means R is actually getting smaller. So it's 1 over 5. You have to make it smaller. And that is the trap that a lot of people fell into with this ratio 1. So now you just do the math and you say whatever I do on the left hand side, I have to go do on the right hand side. So F is also not going to be F anymore. You're going to put a half here at the top of the line. You're going to put 1 over 5, but remember the 1 over 5 is squared at the bottom of the line. And now this you could actually do on your calculator if you wanted to, but you can hopefully do the math. So what we actually get there is now a half, if you tip and times by 25 over 1, which gave us the answer of 25 over 2. So that was